referred to a fixed origin O. The point A has position vector this and B is position vector that. Find AB as a simplified expression in terms of I and j. Okay, that, guys, I hope, as vector questions go, that is not bad. AB is B minus A, little b minus little a, where these are the position vectors. So in this case, it's B is 1, 7. So I always, guys, like to just get out of that IJ form. So it's 1, 7 minus 4, 3, which is equal to, sorry guys, I put a fraction there, which is equal to negative 3, 4. Now he does actually want it in that form, so I have to write minus 3i plus 4j. Okay, that's part A. Part B, find a unit vector that is parallel to AB. Okay, the unit vector, guys, is essentially this with length 1. So what I have to do is find the length of AB and then divide this vector by that length. So this, the length of AB is the square root of 3 squared plus 4 squared. I just ignore the negative, guys, because when you square it, it becomes positive. So 3 squared plus 4 squared is 25. Root 25 is 5. So a unit vector, therefore, a unit vector is a fifth of these. It's this divided by 5. So it's like minus 3 over 5i plus 4 over 5j. Now, if you found the length of this vector, you would see that it is exactly length 1. Okay, that's question 1. Question 2. Oil is leaking from a pipe and forms a circular pool on a horizontal surface. The area of the surface of the pool is increasing at a constant rate of 8. Okay, so I like to write down what that is, guys. That 8 is dA dt, because it's the area, the surface of the area of the surface. So dA dt is equal to 8, and that's constant. Find, in centimeters per second to 3 centimeters, the rate at which the radius of the pool is increasing when the area is this. Okay, so we're trying to find d or dt. That is the rate of change of the radius with respect to time. Okay, now we know that the area is equal to the area of a circle. It's a circular pool. The area is pi r squared. So I know dA dt, if I differentiate this with respect to time, it's equal to 2 pi r times dr dt. Now this is because this is the chain rule, guys. It's because I'm differentiating with respect to time, not with respect to r. If I was getting dA dr, it would just be 2 of these, 2 pi r, but it's dA dt, so it's 2 pi r, the derivative of this with respect to r, times dr dt. It's dA dr, let me write it here, dA dt is dA dr times dr dt. Okay, so now I can figure a few things out. I can say, okay, dA dt I know is 8. So 8 equals 2 pi r times dr dt. I have a problem, however. I want dr dt. I don't have the radius. The other bit of information he has given me is that I want to find it when the area is 50. Okay, so when the area is 50, area equals pi r squared, I can get the radius. So 50 is equal to pi r squared equals 50 over pi, and then r will be the square root of 50 over pi. Let's do that. Square root of 50 over pi. 3.9894. 3.9894. Okay, that means I can then say 8 is equal to 2 pi times 3.9894 times dr dt. Dr dt is therefore 8 divided by this So dr dt is equal to 8 over 2 times pi times 3.9894. Calculator, please. It is 8 over 2 times pi times 3.9894, giving me 0.319. Does he want 3 significant figures? Yes. So it's 0.319. Okay, that, guys, is question 2. Question 3. A particle moves in a straight line. Time t, the velocity is given by this. Find the acceleration of p when t is 3. Okay, that's easy, guys, I think. Acceleration, let's call it a, is equal to dv dt, the derivative of the velocity. And dv dt is here 2t minus 4. And then when t is equal to 3, at t equals 3, a equals 2 times 3 minus 4, which equals 6. Sorry, 2 times 3 minus 4, which is equal to 6 minus 4, which is 2. Okay, easy. 2 meters per second squared. Okay, part B. Find the distance in meters that p travels in the interval 0 to 6. Okay, that, guys, is a bit more tricky than I would like. The first thing I need to note is, because we can't just integrate it because we don't know if it's going forwards or backwards, so I'm actually going to graph this. I want to see what this looks like. Now, t squared minus 4t plus 7, that might actually, now that I think about it, always be positive. Yeah, it is. So this quadratic, guys, is always positive. I actually know it's always positive because the discriminant is greater than 0. So let me just show you this. B squared minus 4ac is equal to b squared is 16 minus 4 times 1 times 7, which is 16 minus 28, which is negative 12. Now, as negative 12 is less than 0, we have no solutions. Therefore, this guy must, if we were to graph it, he must be entirely over the x-axis. He doesn't actually touch the x-axis, which is good for us because now I can just integrate it. So if you didn't even think about that, guys, and you just integrated it, you'd be fine. But it's worth noting that if this quadratic goes underneath the line, then you have to kind of break it into 2 or even 3 pieces, depending on what the interval is. Okay, anyway, we're going to integrate it from 0 to 6 of t squared minus 4t plus 7 dt. Okay, I'm going to go down here, guys, and then we can just do it from here. So this equals square bracket t cubed over 3 minus 4t squared over 2 plus 7t, all from 6 to 0. This is equal to 6 cubed over 3 minus 4 times 6 squared over 2 plus 7 times 6. And again, minus, guys, if I sub in 0, everything here just goes to 0. So nicely, it's just minus 0. And this is, well, let's do this with the calculator. This is just 6 cubed over 3 minus 4 times 6 squared over 2 plus 7 times 6, which is equal to exactly 42, which tells me I'm probably right. Okay, fine. That's part B, 42. Question 4. In triangle ABC, AB is 5x, BC is this, AC is this, and angle ABC is 60. Okay, so we have angle A, B, this is the 60-degree angle, guys. So ABC, let's make that 60 degrees. And I'm not too sure how long these lengths are, but let's put that as 60 degrees. Okay, this is A, B, C. AB is 5x here, BC 3x minus 1, and AC is 2x plus 5. Find to 3 significant figures the value of x. Okay, definitely, guys, I am thinking let's use the cosine rule. So it's this squared, 2x plus 5 squared, equals this squared, 5x squared, plus this squared, 3x minus 1 squared. So this squared plus this squared minus 2 times 5x times 3x minus 1 times cos 60 degrees. Okay, we can then expand this. This is going to give me 4x squared plus 20x plus 25 equals, expand this, 25x squared, expand this, this is 9x squared minus 6x plus 1, and expand this. Cos of 60, by the way, guys, is cos of 60 is a half, so that actually cancels with that 2 there very nicely. So this becomes plus 15x squared. Sorry, it's minus. That'll be minus 15x squared, and then plus 5x because there's 2 minuses like this. Okay, now we're just going to have a quadratic. Let's go with, this is 25x squared minus 15x squared is 10x squared minus the 4 is 6. So this is 6x squared. Let me just do that. Oh, actually, I forgot this 9. So that's super important. Good that I did that little trick that I normally never do. Okay, so this is 34 minus 15 is 19. 19 minus 4 is 15. So that's 15x squared. Okay, that's that, and that. Okay, and then we have minus 6x plus 5x is minus x, minus 20 is minus 21x. That's that, and that. And then we've plus 1 minus 25, which is minus 24, and this equals 0. We then can divide everything by 3. 5x squared minus 7x minus 8 equals 0, and then solve this however way we want. Now he says to 3 significant figures, which tells me it probably doesn't factorize. So let's use the quadratic formula. I have x equals minus b plus or minus the square root of, please, the square root of b squared, 49, minus 4ac, 4 times 5 times negative 8, all over 2a, which is 10. This gives me 7 plus or minus the square root of 49 plus 160. So let me get this straight, guys. That's 20 times 8 is 160 plus 160 plus that is 209 over 10. Okay, this is equal to 7. I'm going to do the plus, guys, because I'm guessing the negative is going to be no good, over 10, and I get this as a decimal 2.145, which to 3 significant figures is 2.15. If we did the minus here, you'll see we get negative value, which is not good, because if I put a negative value here or here, I get negative lengths, which means put a note here actually, guys. Reject negative solution as x is greater than 0. Okay, that, guys, is question 4. Next is question 5. Use algebra to solve these equations. Okay, so we have xy equals 36, and then this, we are going to, guys, make either x or y the subject. I'm not sure which I'd prefer to do. I think we'll go with x. So x, the subject for this one. So x is 36 over y. And then that means instead of x, I can put 36 over y. So this becomes 36 over y times y. So that's my x times y, plus x, which is 36 over y, plus 2y equals 53. These cancel. So I'm left with 36. I'm not actually going to subtract that 36 here, guys, in one step, if that's okay. So I have 36 over y plus 2y equals 53 minus 36, which is 17. Okay, now I have to multiply across by y. So multiply everything by y. This gives me 36 plus 2y squared equals 17y. Then I'll just go over here, guys. 2y squared minus 17y plus 36 equals 0. Okay, then I'll do the a times c method, guys. A times c is 2 times 36, which is 72. Factors of 72 that add to give me 17. It's going to be negative 9 times negative 8. Is 72, because minus 9 plus minus 9 and negative 9 plus negative 8 equals negative 17. Okay, then I do 2y squared minus 8y minus 9y plus 36 equals 0. 2y, I'll just go through this quickly, guys. Y minus 4 minus 9 into y minus 4 equals 0. 2y minus 9 equals 0. Oh, sorry, factors, guys. 2y minus 9 times y minus 4 equals 0. 2y minus 9 equals 0, or y minus 4 equals 0. Y is 9 over 2, or y is 4. Now we have x is 36 over y, so then I'll just write here x equals 36 over y, so over 9 over 2. Keep, change, flip, guys, if you want. This is going to be 36 times 2 over 9. That goes in 4 times, and we're left with 8. So this is 8. And this guy, x equals 36 over 4, which is 9. So the solution, guys, he says solve these equations. The solutions are x equals 8 when y is 9 over 2, and x equals 9 when y equals 4. Okay, that's question 5, guys. This is question 6. Given that y equals this, find dy dx. And then, okay, let's do that first, guys. This is a product rule. So we have y equals 4x minus 3 times e to the 2x. I'm going to write over at the right, u equals 4x minus 3, v equals e to the 2x. Du dx, the derivative of u, is just equal to 4. dv dx is equal to e to the 2x times 2. Chain rule, guys. So many people forget to times that by 2. Chain rule. Then I can write dy dx as u times dv dx. So it's this times this plus this times this. So this times this. Let's just write it like this, guys. Would be my favorite way to write this. This times this plus this times this, which is 4e to the 2x. 4e to the 2x. Okay, good. Let's do dy dx. Secondly, part 2. Show that 4x minus 3 times dy dx equals this. Okay, so first, guys, I'm going to get... There's a number of ways you could do this, guys. You could literally just multiply this by 4x minus 3 and show that, and then multiply this by 8x minus 2 and show that they're the same thing. I think it's only 2 marks, so the way I'm going to do it is if I multiply this out here, I get 8x e to the 2x, 8x e to the 2x minus 6e to the 2x plus 4e to the 2x, which equals 8x e to the 2x minus 2e to the 2x. Now this is equal to, guys, you can kind of see something I'm looking for here. Is if I take out the e to the 2x, I get 8x minus 2e to the 2x. So that is dy dx. Now, if I multiply this by 4x minus 3, so I'll do, sorry, this one here. So I'm going to do 4x minus 3 times this times 8x minus 2 e to the 2x. That's this times dy dx. Well, that equals 8x, if I just swap this and this, which obviously I'm allowed to do, 4x minus 3 e to the 2x. Well, 4x minus 3 e to the 2x is y. So this is equal to 8x minus 2 times y, which is what we were asked to show, q, e, d. Okay, finally, differentiate. This is part B. Differentiate this with respect to x. So let's just say, y equals, guys, y equals sine 5x over x minus 3 squared. Okay, this is quotient rule, guys. So at the side, I'm going to do u is sine 5x, v is x minus 3 squared. If you want to call this f of x and g of x, guys, this is in the formula booklet, formula sheet. So du dx is cos 5x times 5, because it's a chain rule. So it's 5 cos 5x, and dv dx is power rule 2 times this to the power of 1. So it's just that. It's like multiplied by 1 if you like, the derivative of what's inside the bracket, but obviously I don't have to write times 1. Okay, so the derivative dy dx, quotient rule, guys, is v du dx. So it's x minus 3 squared times du dx. I'll put the 5 here if everyone's okay with that. So it's 5 times this cos 5x, so that's v du dx, minus u dv dx, which is this times this. If you're okay, guys, I'll do that. U dv dx, yeah, that is this. So this minus this times this sine 5x all over v squared, which is v squared x minus 3 squared, which is to the power of 4. Be careful. Now, I think that's it, guys, because he doesn't say in any particular form. So we're good. Okay. Question 7. The sum of the first n terms or an arithmetic series is a of n, where a of n is this. Find the first term of the common difference. Okay, so guys, I'm going to just straight off write out this series, right? So it's 4r plus 5. So the first term is 4 times 1 plus 5, because we're starting with 1. So that would be 9. So 9 plus, when r is 2, 4 times 2 plus 5, which is 13. And then it goes from there up in 4s. Sorry, it's plus if we're making a series. 17 plus 21 plus etc. So that's what this sigma notation whole thing means. Okay. So the first one, this makes my first question a bit easier because the first term is obviously just 9. And then the common difference is obviously just 4. You can see it very clearly here. It's also that whatever this 4r is there. Okay, that's part A. Part B. The sum of the first n terms of a geometric series is g of n, where g of n is this. For this geometric series, find the first term, the common ratio. Okay, let's do the same thing, guys. Sub in 1. We get 4 times 3 to the power of 0, which is 4 times 1, which is 4. So the first term is 4. The next term, we sub in 2. 4 times 3 to the power of 2 minus 1 is 4 times 3, which is 12. Then the next one, sorry, it's plus again, guys, plus 12. Then the next one is, we sub in 3. 3 minus 1 is 2. 3 squared is 9. 9 times 4 is 36. So you can see what's happening here. We're starting with 4 and we're multiplying by 3. So answer to question 1, the first term is 4 and the common ratio is 3. Again, without expanding it out like that, it's literally just that 3 there and the 4 is there. But it's yeah, I always say it's beneficial to expand out like that. Okay, then he says, find the value of n for which a14 minus 6 equals g of n. Okay, first, guys, let's get a14. So a14 is the sum of the first 14 terms. So it's from the formula sheet, guys, it's 14 over 2, 2a, which is 9, plus n minus 1, which is 13, times d, which is 4. Okay, this is 7 times 18 plus 13 times 4, close brackets, 490. So this is 490. Okay, so a14 minus 6 is this minus 6, which is 484. Okay, is that right? A14 is this, a14 minus 6 is 484. Okay, so if we go to g of n, so we are looking for the sum of a geometric sequence, guys, is a times r to the n minus 1 over r minus 1. This is when we use this one for r is greater than 1, which this one is. Okay, so now I can say a into this, which is 4. So 4 into r, which is 3 to the n minus 1, all over 3 minus 1, which is 2, equals 484. Okay, this, however you want to do this, guys, that's actually once and twice. So I divide this by 2. I get 3 to the n minus 1 equals this divided by 2 is 242. Add 1, 3 to the n equals 343. And that, guys, is a nice number because 3 to the power of something gives you 343 now. Watch, we can just do it like this. 3 times 3, so squared is 9. Power of 3, power of 4, and the power of 5. So n is equal to 5 because 3 to the power of 5 is 343. Okay, that, guys, is question 7. The point A has coordinates 2, 6. The point B has coordinates 6, 8. And the point C has coordinates 4, 2. Find the exact length of AB. Okay, so, guys, let's do this. AB, so this is A and this is B. Okay, so sorry, we have to do all of these. So, fine. AB is they're all the distance formula, guys. So it's the square root of, so AB will be 6 minus 2 squared plus 8 minus 6 squared. And this is equal to exact value, guys, he wants. So I'll give him the exact value. This is 16 plus, that's 16 plus 4, which is 20. So that is root 20. Part 2, what do we want? BC. So BC is equal to the square root of BC. So BC. So 6 minus 4 squared plus 8 minus 2 squared. This one is equal to square root of 4 plus 6 times 6 is 36, which is 4 plus 36 is 40. And then finally, this one, AC, is equal to the square root of sorry guys, what's going on here? The square root of, I'll just do this one in my head. It's 4 minus 2 squared, so it's 4 plus 16, so it's 20. So this is root 20, root 40, root 20. I'll leave it like that. Although you could write that, guys, as root 4 times root 5, which is 2 root 5. And you could write this as root 4 times root 10, which is 2 root 10. And you could write this as obviously 2 root 5 as well. But they haven't asked for that, so fine. Part B. Find the size of each angle of triangle ABC in degrees. Okay, that's quite annoying. It's going to make me do all of this. Okay, fine. Let's go. We'll draw the triangle first, guys, or draw something. So this is, so we'll call it A, B, C. This is the bigger one, so we'll call, that's my, no, actually, sorry, I should do it the other way around. This is A, B, C, because AB is the biggest one. No, sorry, BC is the biggest one. So let's call this A, B, C. Okay, AB is root 20, AC is root 20, and BC is root 40. Okay, now note, guys, these two angles are actually going to be the same because it's an isosceles triangle, so okay, that's saving me a bit of work. But let's call this angle X. So now I can say root 40 squared. So this is why it's nice to keep them as roots, guys. So this is my A squared, cosine rule. A squared equals B squared plus C squared minus 2BC cos A, which in this case we've called X. So it's going to be this squared, which is 40, equals this squared plus this squared, 20 plus 20, minus 2 times 20 times 20, which is, no, sorry, it's 2 times root 20 times root 20, which is 2 times 20, which is 40, cos X. Okay, this is therefore 0. Okay, I see what they're doing, guys. This is 0 equals, if I subtract the two 20s, minus 40 cos X, which means cos X equals 0, which means X is equal to 90 degrees. And if X is 90 degrees, then the other ones have to be 45. So this is 45. This is 45. Okay, so let's just write it like this. So angle ABC equals 45. Angle ABC is 45. ACB is 45, and angle BAC equals 90, all in degrees. Okay, Let us continue. Part C. The points A, B, and C lie on a circle with center P. Find the coordinates of P. Okay, so this is getting tricky, guys. Let me draw this circle. Okay, now I'm just going to go over here. This is part C. And I'm going to draw a circle. Now, guys, the fact that it's... Let me draw a bigger circle. Or a better circle, I should say. Okay, that's better. Now, the fact that that's 90 degrees. So, guys, he says, like... He says ABC lie on a circle with center P. But because it's 90 degrees, that tells me, and that's obviously part of the... part of the question here, that this goes through the center. So this is a diameter. Because remember, the angle at the center... Sorry, the angle in a semicircle is 90 degrees. So this is my ABC triangle. This is A, this is B, and this is C. So that means that these coordinates, the coordinate of A, my 2, 6, this is 2, 6, B is 6, 8, and 4, 2. So this is 6, 8, and this is 4, 2. Okay, so the center, this is a diameter. So the center here is actually just going to be the midpoint of BC. So that's actually, that's kind of tricky, guys, the way I did that. But yeah, the idea is that you know this is 90 degrees, hence you know this is at the angle in the semicircle. So there you go. So the midpoint is 6 plus 4 over 2, 6 plus 4 over 2, comma 2 plus 8 over 2, which is equal to 5, 5. So the center of the circle is 5, 5. Okay, part D. Find the exact length of the radius of the circle in the form root A. Okay, well, actually, that's not too bad now because we're just getting the distance between 2 points. So this is 5, 5. Okay, part D. Part D. The radius is equal to the square root. That's annoying. The square root of 5 minus 4. 5 minus 4 squared plus 5 minus 2 squared, which is equal to 1 squared plus 3 squared, which is equal to root 10, which is the answer. Okay, that, guys, is question 8. The curve C with equation y equals f of x passes through the point with coordinates this, given that f dash of x is equal to this, show that C passes through the origin. Okay, so guys, this is a classic. We're given the derivative and we need to find f of x. How do we do it? We do it by integrating the derivative. So the integral of this, x cubed minus x squared minus 4x plus 4 dx, like this. This will give me x to the 4 over 4, add 1 to the power, divide by the new power, minus x cubed over 3, minus 4x squared over 2 plus 4x. This just becomes 4x. And then finally, guys, very importantly, don't forget plus c. We then sub in the y and the x. So I'm going to say at, well, actually, I don't even need to put that. I'm just going to put negative 28 over 3 equals negative 2 to the 4, negative 2 to the 4 over 4, minus negative 2 cubed over 3, minus 4 times negative 2 squared over 2, plus 4 times negative 2 plus c, negative 28 over 3, equals, this is 16 over 4, which is 4. This is going to be plus, because there's actually 4 minuses, 8 over 3, this is going to be minus 2 times 2 is 4, 4 times 4 is 16 over 2 is 8. And then this guy is also minus 8 plus c. Okay, so minus 28 over 3 equals, I'm going to guess this is going to be equal to negative 28 over 3. So guys, this is 12 over 3 plus 8 over 3 minus 24 over 3 minus 24 over 3 plus c. This is minus 48 plus 20 is minus 28. So minus 28 over 3 equals minus 28 over 3 plus c. C is therefore equal to 0. Therefore, f of x, well, f of x equals this, x to the 4 over 4 minus x cubed over 3 minus 2x squared, if I simplify that, plus 4x, no c, and then when x is 0, so f of 0 equals 0 minus 0 minus 0 plus 0, which is 0, therefore passes through 0, 0. Okay, that's part A. Part B. Show that C has a minimum point at x equals 2 and a maximum point at x equals 1. Find the exact value of the y-coordinate of each of these points. Okay, let's do part I first. So it has a turning point, a stationary point, let's call it SP, stationary point when f dash x equals 0. So we need to solve this. So guys, when f dash of x equals 0, x cubed minus x squared minus 4x plus 4 equals 0. Okay, now we need to show that it has a minimum point at 2 and a maximum point at 1. So when x equals 2, or I should just let's get f of f dash of 2 equals 8, well, it's 2 cubed minus 2 squared minus 4 times 2 plus 4, which is equal to 8 minus 4 is 4, minus 8 is minus 4, plus 4 is 0, so that is 0. And f dash of 1 is 1 cubed minus 1 squared minus 4 times 1 plus 4, that is 0, minus 4 plus 4 is 0, that is also 0. So they have stationary points at 2 and 1. So I'm going to write that. Therefore, stationary points at x equals 1 and x equals 2. But he wants us to show that it's a minimum at 2 and a maximum at 1. Okay, in order to show it's a max or a min, I need to get the second derivative. Okay, so guys, I'm going to, let me just bring this down here. Okay, I am going to, this is bi continued, bi continued. Okay, so we know the stationary points at x equals 2 and x equals 1, but I now need to get the second derivative, f dash dash of x. So that is 3x squared multiplied by the power, subtract 1 from the power, minus 2x minus 4. This is the second derivative. So at, well, let's get f dash of, or f dash dash of 2. So f dash dash of 2. If it's a minimum, the second derivative should be greater than 0. So let's do f dash dash of x is greater than 0, and for maximum, f dash dash of x is less than 0. So this is going to be 2 times 2 is 4. Well, let's do it. Minus 2 times 2 minus 4, which is equal to 4 times 3 is 12. 12 minus 4 is 4. So 4 as 4 is greater than 0, minimum. As 4 is greater than 0, it's a minimum at x equals 2. Then get f dash dash of 1, which is 3 times 1 squared, minus 2 times 1, minus 4, which is 3 minus 2 is negative 1, minus 4 is negative 5. This is greater than 0, so as negative 5, sorry, is less than 0, we have max at x equals 1. Okay, then he says find the exact value of the y coordinate at each of these points. So let's go to BII here. The exact value of the y coordinates, well, we know y is equal to, I had it up here, guys, y, or f of x, so y is equal to this guy. It's x to the 4 over 4 minus x cubed over 3 minus 2x squared plus 4x. So let's get the y coordinate at 2 and 1. So let's say at 2, y equals 2 to the 4 over 4 minus 2 cubed over 3 minus 2 times 2 squared plus 4 times 2. This is equal to 16 over 4, which is 4, minus 8 over 3 minus 8 plus 8. This is going to be 0. We've 24. I have 24 over 3. Sorry, 12 over 3 minus 8 over 3 is 4 over 3. Then at x equals 1, we have, let's do it here, at x equals 1, at x equals 1, y equals, and then we just sub in 1 in here, so this is just going to be 1 over 4 minus 1 over 3 minus 2 plus 4. Feel free to use your calculator, guys. This is 3/12 minus 4/12 minus 24/12 plus 48/12. That's 24 minus 4 is 24 minus 4 is 20 plus 3 is 23/12. So this is 23 over 12. Okay, so that's the y coordinate at each of these points. Then he says the curve is another turning point at A. Find the coordinates of A and determine the nature of this at this turning point. Okay, so if it has another turning point, then the derivative, well, the derivative is 0 at that turning point. Now, we know that the derivative, guys, let me get back to the derivative, x cubed minus x squared minus 4x plus 4, x cubed minus x squared minus 4x plus 4 minus 4x plus 4 equals 0. Now we know, everybody, that, so we basically want to solve this cubic equation. We know that f dash of 2 is 0 and f dash of 1 is 0. So we know the factors of this are x minus 2 and x minus 1. These are two linear factors. And then a third factor has to be, well, it has to be x because it's x cubed, not 2x cubed or 3x cubed. So this has to be x. And then I just need to figure out what would I multiply this by to get the 4. So minus 2 times minus 1 is minus 2. Or sorry, it's plus 2 times 2 times plus 2 will give me the 4. So this is plus 2 here. So that's kind of like a quick way of factorizing. If you really wanted, guys, you could divide the long way, but this is only it's only a 3-mark question. So the long way would be to actually divide this by x minus 1 or x minus 2 and then get the factors that way, but that's kind of a quick way to do it. So therefore, Therefore, the third coordinates of A, so x coordinate of A, x coordinate of A is -2, because it's where x plus 2 equals 0. So it's -2. And then, this is quite a long, difficult question, guys, but it is further maths. So f of -2, I have to get, f of -2 is, okay, we have -2 to the power of 4 over 4 minus -2 cubed over 3 minus 2 times -2 squared plus 4 times -2. Obviously, guys, you can use your calculator here. This is 16 over 4, which is 4 plus 8 over 3 minus 8 minus 8. And this is equal to 12 over 3 plus 8 over 3 is 20 over 3 minus 48 over 3, which is minus 28 over 3. Okay, so guys, just use your calculator. That is the coordinates of A. Therefore, A is -2, -28 over 3. And then he says, finally, determine the nature. So this means we need to go to find the second derivative, f dash dash of -2. Where was my second derivative? It was here. So it's 3x squared minus 2x minus 4. So it's 3x squared minus 2x minus 4. 3x squared minus 2x minus 4, which is 12 plus 4 minus 4, which is 12, which is greater than 0 if it's greater than 0. Therefore, it is a minimum point. Okay, that is question 9. The roots of the equation x squared plus 3x minus 5 equals 0 are alpha and beta. Without solving, find alpha squared plus beta squared. Okay, so definitely, guys, to start off, we're going to write down alpha plus beta using our rules. This is -3. It's -3 over 1, if you like, if there's a 1 there. And alpha beta is equal to -5 over 1, which is -5. Okay, then to get alpha squared plus beta squared, we are going to do alpha plus beta all squared like this. Now this equals alpha squared plus 2 alpha beta, hopefully guys you know how to expand this out, plus beta squared. So that means alpha squared plus beta squared is equal to, it's like the right hand side, this minus the 2 alpha beta. So it's alpha plus beta squared minus 2 alpha beta. Now we have alpha plus beta, it's -3, so that's a -3 squared. And we have alpha beta, it is -5, so it's -2 times -5. This is 9 plus 10, which is 19. Okay. Then he says find the value of alpha to the 4 plus beta to the 4. Okay, now to get that, okay, that's kind of tricky, guys. This is part I. To get alpha to the 4 plus beta to the 4. Now you could do alpha plus beta all to the 4, but that would take you a while to expand. It would be easier if we just do alpha squared plus beta squared to the 4. Sorry, squared. Sorry, alpha squared plus beta squared squared. And this will give me alpha to the 4 plus 2 times this, which is 2 times alpha squared beta squared plus beta to the 4, because beta squared times beta squared is beta to the 4. And then a similar way I did above, I'm going to do alpha to the 4 plus beta to the 4 equals this, alpha squared plus beta squared squared minus 2 times alpha squared beta squared. Okay, now this equals alpha to the 4 plus beta to the 4 equals this squared. Now we know this is 19. So that's 19 squared. 19 squared like that. Minus 2 times, that's like alpha beta squared, which is negative 5 squared. Okay. 19 squared is 361. Minus 2 times 25 is 50, minus 50. So this is, again, guys, feel free to use your calculator, but that is 311. Okay, that's part A. Part B. Show that alpha minus beta is equal to root 29. Okay, so we have alpha plus beta. We have alpha beta. We don't have alpha minus beta. But what we can do, guys, similar to getting alpha squared plus beta squared, if I do, let me just try this, guys, alpha minus beta squared. So if we square this, we can get alpha squared minus 2 alpha beta plus beta squared. Now this is good because we have alpha squared plus beta squared is 19, and we have alpha beta, it's negative 9. So that means alpha minus beta squared is equal to alpha squared plus beta squared, which is 19. That's that plus that, minus 2 times alpha beta, so minus 2 times negative 5, which is just plus 10 if you like. So alpha minus beta squared is 29, and then alpha minus beta is equal to root 29, which is what we wanted to show. Okay, that's part B. Part C, down here. Factorize alpha to the 4 minus beta to the 4 completely. Okay, so this, guys, is a difference of 2 squares. This is actually equal to like alpha squared squared minus beta squared squared. So this is equal to alpha squared plus beta squared times alpha squared minus beta squared. And then this, squared. And then this is also another difference of 2 squares. That's why it says completely, guys, because we can go again. This is equal to alpha squared plus beta squared. I can't do anything with that. And then this is alpha plus beta times alpha minus beta. So that is the factors of this completely. Okay. Part D. Then he says, find the exact value of alpha to the 4 minus beta to the 4. Okay, so that means alpha to the 4 minus beta to the 4. So I think I have all these values. So alpha squared plus beta squared is 19. Alpha plus beta is negative 3. And alpha minus beta is root 29. So this is root 29. So this is going to give me just 19 times 3, guys, is 57, and negative 57, root 29, and I'll just leave it like that. I think he said the exact value, so I don't want to put it as a decimal, so it's negative 57 root 29, like that. Okay, part E, I'll do it over here. Okay, given that beta to the 4 is p plus q times root 29, where p and q are positive constants, find the value of p and the value of q. Okay, so now, guys, we have to find, excuse me, beta to the 4. Okay, so we know alpha to the 4 minus beta to the 4 is equal to this. So, let me have a think about this a second. Okay, yeah, we know the value of alpha to the 4 plus beta to the 4. Let me see what it is. It's 311. Okay, so alpha to the 4 plus beta to the 4 is equal to 311. And alpha to the 4 minus beta to the 4 equals negative 57 root 29. Okay, so we're trying to get beta to the 4. So this is a bit like simultaneous equations. But if I subtract them, that will get rid of the alphas, and it'll give me 2 beta to the 4 equals, now this one, guys, I am going to use my calculator. 311, it'll be plus 57 root 19, so 368. So that is 368, 368 root 29. No, sorry, guys, I've done something stupid. Sorry, I take that back. I forget I did that. I can't do that because this is root 29. So it's 311 plus 57 root 29. Okay, fine. Because it's minus is plus, but I can't add them together, of course. So finally, we have beta to the 4 is equal to 311 over 2 plus 57 over 2 root 29. So therefore, if you like, P is equal to 311 over 2 and Q is equal to 57 over 2. Okay, that, guys, is question 10. Question 11, figure 1 shows a right pyramid, vertex V, square base, ABCD side 16, size of angle AVC is 90. So that, guys, is like this angle here, AVC. That's like 90 degrees there. Okay. Show that the height of the pyramid is 8 root 2. Okay, so the height of the pyramid, guys, goes straight down into the center of this square here. Okay, now I think 8 root 2, I think we'll use this right angle thing, guys, to show this. So, okay, imagine this triangle here. This 2 is a right angle. And because this, let me continue this line here down here. Because this is 90, oh, didn't want it to do that, but whatever. Seeing as this is 90, this has to be 45 because it's basically half. It's like half there, and it's basically like half there and half there, half of the 90. So that is 45 degrees. Okay, so to show that the height is 8 root 2, I need to get this length here. Let's just call this M for now. Okay, so this is also 16, guys. So AC, let's get the length AC, it's Pythagoras' theorem. So that's the square root of 16 squared plus 16 squared. I think, guys, that's a nice number, but let me just do it just to be sure. That is 16 squared plus 16 squared. Oh, maybe it isn't. 16 root 2. Okay, so that's 16 root 2, which means AM, which is half of that, is 8 root 2. Okay, now we're trying to show the height is 8 root 2, but well, we know this angle is 45, so let's call the height H. So I can say the tan of 45 degrees is equal to 8 root 2 over H, because that's like our opposite of this angle here is this guy, which is our 8 root 2, and then 8 root 2. So opposite over adjacent, which is H, which is this. Now tan 45, guys, is 1, so that means H equals, well, because to show that, guys, I'll say here, well, 1 equals 8 root 2 over H. Therefore, H is equal to 8 root 2. Okay, that's part A. Part B. Find in centimeters the length VA. Okay, so I have this and I have this. So VA is just going to be Pythagoras' theorem. It's the hypotenuse. It's going to be 8. It'll be the square root of 8 root 2 squared plus 8 root 2 squared, because that's 8 root 2 and that's 8 root 2. Okay, 8 root 2 squared is 64 times 2, 128, plus 128 is 256. Okay, that's maybe the nice number I was thinking of, guys. That's 16. Use your calculator if you want. 64 times 2 is 128, times 2 is 256. The square root of 256 is 16, part C. Find in centimeters the exact length of the perpendicular from D to VA. Okay, so the perpendicular, guys, is from D here to VA. So it's from D, the point, to VA, but perpendicular. So, like there, perpendicular means obviously right angles. Okay, so find this length. Now we have, guys, that this length VA is 16, but remember, this is a right pyramid with a square base. So if that's 16, then this is 16. So they're all 16. And this is 16. So this is actually, although it doesn't look like it, not drawn to scale, this is an equilateral triangle. So this, again, certainly doesn't look like it, but this is actually meeting halfway through. Because if this was, let me try and draw equilateral triangle. If this was equilateral, like say that, then that's not equilateral either, but the perpendicular would be exactly halfway. This perpendicular would be halfway, and this perpendicular would be halfway. Again, it's not a great drawing, but you get my point. So this is actually 8 and 8. So this length is 8, and this length is 8. So it's 8 and 8, which is kind of like half the 16. Okay, so now if I have that's 8 and that's 16, I can just use Pythagoras again. Thank you, Pythagoras. So this is, let's call it x. No, it's not the hypotenuse. 16 is the hypotenuse. So it would be x squared plus 8 squared equals 16 squared. X squared is the square root of 16 squared minus 8 squared, which is, let's do that with the calculator, that is 16 squared minus 8 squared, 8 root 3. So that distance is 8 root 3. Okay, then he says find in degrees to one decimal place the size of the angle between the plane VAB, so that's VAB, and the base ABCD. Okay, so guys, I'm going to move down here. I have another one, but I'm going to bring in some of the distances that we had. Okay, so he wants the distance, the angle between VAB, that angle here, and the base ABCD. So VAB and the base. So this is the height which we have straight down to the middle, and then if I want the angle between the base and the plane, this would be a right angle triangle here, and he's actually looking for, the angle he's looking for is actually this one here. That's the angle between the base, let's call it theta, between the base and the angle between the base and this plane VAB. So if you just kind of try to visualize it there. Okay, now this is just half of 16, which is 8, and that height we know is, well, it's there, it's 8 root 2. So now we can just do tan of theta. Tan theta equals 8 root 2 over 8, which is equal to root 2, and then theta is, this is part D, guys, the inverse tan of root 2, which is inverse tan root 2, close brackets, 0.99. I'm in radians, guys. I want in degrees. Degrees, please. And then back. Okay, can I do that again? Okay. The inverse tan of root 2 is 54.7 to 3 or to 1 decimal place. Okay, 54.7 degrees. Okay, then he says, part E, find the obtuse angle between the planes VAB, and VAD. Okay, this, guys, is tricky. I'm actually going to delete that. Okay, now when you're getting the angle between two planes, guys, so, well, first, obviously, try to get your head around what planes we're talking about. So we're talking about this guy, and then this front one. So it's that angle, the angle along this line. So the next thing you do is you draw, well, let's draw a line along the edge of where the two planes meet. So the angle is going to be at this line. Now, importantly, and this is why they've kind of helped you here by getting the perpendicular from D to VA. When you get in the angle, you have to get the angle between two lines that meet this meet it perpendicularly. So, or meet it at right angles would be a better way to do it. So we actually have this. We have this length here. This length was what length was that? Sorry. D to VA. That was 8√3. Okay, so this angle, or sorry, this length is 8√3. Now, the other angle perpendicular to this along this plane would be some line going, now it's hard to draw this or visualize it, guys, but it's some line going along this plane, but it has to be perpendicular to the red line. Now, because the red line, or sorry, the two faces are basically the same shape, because this front face is the exact same face as this face on the side, then that perpendicular line would actually go from the same place to B, because it's exactly the same kind of situation. If you just rotated the pyramid, you would see that, that from the symmetry or whatever of the pyramid, you would see that a line perpendicular to this red line along the face VAB would go to B. Okay, and the length of that would be the same. Again, similar kind of situation. It's just the same shape. So that would also be 8√3. Now we're trying to find this angle here. Let's call this angle, guys, I don't know, whatever. Let's call it Y. Okay, so that angle is Y. And we need just that third line, which we actually have. That third line here, that is the same distance as whatever. I don't like the way it does that. Anyway, whatever. That third line, BD, is the same length as AC. So BD, that was actually AC that I got here, 16√2. So that BD is 16√2. Here to here, that is 16√2. Okay, and that 8√3, guys, is with this line here. And now I can just use the cosine rule. So cosine Y is equal to this squared, 8√3 squared, plus 8√3 squared, minus 2 times 8√3 times 8√3, which is 8√3 squared. Sorry, this is not the cosine rule. What am I doing? Cosine rule is this squared, 16√2 squared, equals this squared plus this squared minus 2 times this times cos of y. Okay, and then you can rearrange this to cos of y equals this squared plus this squared, which is just 2 of these. So 2 times, or let's go with, 2 times 8√3 squared, minus this squared, 16√2 squared, all over 2 times 8 root 3 squared. Okay, just make sure you've rearranged that correctly, guys, and then we can use the calculator. Okay, so I can say inverse cos of fraction 2 times 8 root 3 squared minus 16 root 2 squared over 2 times 8 root 3 and 8 root 3 squared. Hope this is right, guys. I don't have to do this again. And I get 109.47, which is right, thankfully. 109. I think he wants to 1 decimal place, so 109.5 degrees. Okay, that's it, guys. That is question 11, and that is paper 2 finished. I'll see you in the next paper.